friends, welcome back to our channel. So in the previous session we have seen the insertion, how to insert an element to the linked list and how to insert the element at the ending, beginning and the specified location. Now in this session we will see how to delete an element from the linked list. So we'll consider one existing linked list, some with 5 nodes, and from that 5 nodes we will see the deletion operation. So how an element is deleted from the beginning, how the element is deleted from the ending position, and how the element is deleted from the specified position. Right? Now let us see that. So linked list. So in that linked list we are seeing the deletion operation. So first let us see the linked list, existing linked list. So let us consider 5 nodes. Let it be, these are the 5 nodes, some 10, 20, 30, 40 and a 50. The memory of this 1000, 2000, 3000, 4000 and 5000. So we know that linked list means 2 fields will be there. One is the data field, another one is the address of the next node. So here the address of 20 will be stored. Here the address of 30 will be stored. Here the address of 40 will be stored. And here the address of 50 will be stored. And here it is a last element, so the address will be null. Right? So this null indicates the last element of the list. Now consider this as head and this as tail. Right. Now first delete at beginning. Delete an element at the beginning. So what is the output? First we will see the output, then we will write the code according to the output. Right. So we know that if you delete the element node 10, the first node will be C. So the overall only 4 nodes will be available, and the first node will be 20, 30, 40 and 50. And here the memory location is 2000, 3000, 4000 and 5000. Now here it will be 3000, it's a 4000, it's a 5000 and it's null. Now so this is the output. That means if you delete at the beginning a node, this 10 will be deleted, right? So the first element will be, so this is the head and this is the tail. There is no change on tail, there is a change in head. So here we need not read any value, because here we are not inserting but we are deleting the element. So in the linked list, just deleting an element, so delete means simply disconnect the link. Disconnect the link. Right? So how to disconnect the link? So here we said that this is a link between one node and another node. So how to disconnect this link? Means placing null at address position. Address field, not a position, address field. Right? So by placing null at address field, that node will be get disconnected, because we said that number of elements will be occupying in different locations and we are establishing a link between one node and another node by placing the address of node in the present node. So here the node is 20 and the address stored is the address of 30. That means the second element address will be stored in first node address field. So here if you place null at the address field, automatically the link will be disconnected. So here if you observe here, if you place null here, then automatically there will be no link between the first element 20 and 30, because so it points to the address of the location, address of the node, the second node. So here the address is null, so it doesn't point to the another node. So automatically this will be the single node. So this is a linked list. So in such a way that we have to disconnect the link, that means we are deleting the element. See, we will see one by one step. Now, hope you understand this one, right? Disconnecting the link, that means placing null at the address field. So whatever the element we want to delete, we have to place the null in that particular element. So here, if you want to delete the 10, in the place of 2000, we have to place null. Automatically this node will be disconnected from the linked list. So in order to place null, see, we have to move the head to second element, because after deleting this node, the head will be on element 2, node 2. So see, just remember, we need not modify the head, right? So we can take one temporary variable and we can assign the head to the temporary variable. So temporary is equal to head. Now what we have to do, see, temp is equal to head. So here the temp is also here itself, it is pointing here. Now the temp of next, head is equal to head of next. So after executing this statement, head will be moved to here. Head is equal to head of next. Now we have to place null at the address field. So temp of next is equal to null. Automatically here the 2000 will be replaced with null. Right? So this connection will be disconnected. The connection will be disconnected. So the output will be this one. This one is the output. Right? Hope you understood. So here we have to take care about the execution of a statement. First we have to execute this statement and then the second statement. Right? We should not change the order of the statement, because see, I will show you that. Temp is equal to head, so we are assigning the temp. So if you place temp of next is equal to null and head is equal to head of next, see, the same, both are same, but these two statements I have been swapping, right? So first I am initializing null and then I am moving the head. So if you write this one, see, 2000 and this is the head. So if you execute this one, first temp of next is equal to null. So obviously temp of next is equal to null, right? Next we have to move the head. Head is equal to head of next. So here head of next, there is no address. So where the head should be moved? So it doesn't know where to be moved because the address is, we are assigning null. So here we can't move the head, right? So that's why, that's the main drawback here. We can't move the head after placing the null, right? So in the first step we are placing the null at the address position. So automatically the link has been disconnected. So we can't move the head to the second element because there is no link from the first element to the second element. That's why we have to first move the head and then we have to place the null. So we have to take care about the link. So first we have to move and then we have to disconnect the node, right? So this is the wrong step, right? This is the right thing. So this is the simple logic if you want to delete an element at the beginning position. Now, so hope you understood this one, right? Next we will see the second thing. Right. here it is a tail and this is the out. This is the head. Delete at end. Now see, if you observe here, sorry, see, if you observe here, in the second case we are deleting an element at the end. So here we are deleting the 50, the number 50, so that the tail should be moved to 40 and the address field of this 40 node should be null, because null indicates the last element, right? So now let us see this one. Here also we should not change the head value, so that's why we are taking temporary as a head, right? We are taking temporary as head. Next, so we have to move till 30. So while temp of next not equal to tail, so it doesn't not equal to tail means here the temp will be here. So we have to travel. Temp is equal to temp of next. So just we are writing some iterative statements, right? So this iterative statement means until the temp of next is equal to tail, the temp will be moving towards its right. So temp of next, temp of next, temp of next is null. So the temporary will be here itself, right? Sorry, here. Sorry, here the temp will be here, right? So now simply place the temp here, so it ends the loop, right? Now place temp of next is equal to null. Automatically here, instead of writing 5000, we are just replacing it as null. If you place null, automatically the link has been disconnected, right? And the link has been disconnected. Now see, sorry, tail is equal to temp. Now initialize, I mean we have to change the tail. So here it will be tail. Just move here. Here we are just assigning, right? So in the previous session, I mean in the previous case, we are moving the head. We have to move the head, right? So here the last element, so we are just assigning the temp to tail. Okay, so this is the code for deleting an element at the end position. Hope you understood here, right? So this is the output. We got the output. So just we have to disconnect the link. So if you disconnect the link, automatically the element is deleted in our perspective, right? So how to disconnect the node? So placing the null value at the address field of that particular node, the previous node. Now see the third case, specific position. Delete at specific position. Some 5000, right? Here it is a tail. Now specific position. So here we require a position. So where it should be inserted, I mean deleted, which element should be deleted. So here we have to read the position, scanf %d ampersand position, right? So until that position, let it be POS is equal to 2, right? 2, 0, 1, 2. That means this element. We need to delete that particular element. Now, so for that we have to move the head from 0th position to position -1. So that means simply see here in this field we have to place the address of 40. And here we have to place null, or we can simply leave that one. So here instead of 3000 we have to link this node with the 40th node. Now for I is equal to 0, I less than position minus 1, I plus plus. So until this condition fails, we have to move the temporary variable. So before we have to initialize head to temp. So we need not change the head value. Temp of next, sorry. So temp is equal to temp of next. Automatically until the temp reaches the position minus 1, it will move. So now the temp will be in this position, right? Now see, temp of next, here instead of 3000 we have to place here the 4000, that means a address of 40. So in order to get this one, simply we can write temp of next. So temp of next means 3000, that means a 4000 will be there, and sorry, temp of next means 3000 and next, temp of next of next, that means temp of next 3000 of next 4000, right? So this is a referential pointer, right? So temp of next means 3000 of next, that means at the position of 3000 what is the address? 4000. Here if you put data, automatically we can get 30. Oh, sorry. So temp of next means 3000, 3000 of data means 30. Here instead of data we are placing next. So temp of next 3000 of next. So in the 3000 what is the address? 4000. So 4000 will be placed here, temp of next. Okay, don't get confused. So just we are linking, right? We are traveling forward. So if you want to place 5000, you can simply write temp of next of next of next. If you want to print the data, directly we can print the data. Here if you print the data, we can get the value. Here we are printing the address, we are assigning the address. So temp of next of next. Temp of next is 3000. 3000 in the 3000 position, what is the next? 4000. So 4000 will be assigned here in the place of 3000, right? So simple, that's it. So we need not, so if you place this one, this is null, this is 2000, this is 4000, this is 5000, this is 5000, this is 4000, this is 2000, this is 1000. See, after executing this code, we will get this one because we are placing 3000 to 4000. So obviously the link will be disconnected here, and the link will be connected to here. So this node will be left single. This node will be left single. So after executing this code, the link, so here instead of 3000 we are placing 4000. So automatically the link is established between 20 and 40. So this node will be single. So in our perception it is eliminated. So there is no element, there is no connection for this element with our linked list elements. So that's why we can simply ignore. So the output will be this one. If you want to delete an element from the specific position, delete from specific position, simply we can read the position, we can travel this temp until the position -1, and then we can place the next node address into the present node. That means temp of next is equal to temp of next of next. So 5000 will be assigned here. 4000 will be assigned here, right? So there will be a link between this 30 node will be disconnected from 20 and 40, right? So this is about the deletion operation. So hope you understood this session. So if you are having any doubts regarding this insertion and deletion, feel free to post your doubts in the comment section, so that I will definitely try to clarify all your doubts. And definitely I will post the link of creation and display and insertion, the videos, in the description section, so that you can refer that for a better understanding, right? So once we complete all these things, we will I will make one more video for implementing all these operations: insertion, creation, display, deletion, right? In the next session we will see the reverse and count. So how to reverse the linked list and how to count the number of nodes presented in the linked list, right? So we'll stop here. So in this session we have seen the deletion operation, how to delete an element from the linked list at the beginning, from the deleting an element from the linked list from ending, and from the specific position, right? So if you really understood my sessions, like my sessions, share my sessions with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.